All right. Looking at nomenclature of alkanes. So when you say nomenclature, all right, nomenclature has to do with naming. All right, trying to get the name of an entity. All right. If someone asks you your nomenclature, you would start with your surname, then your first name, then your middle name will come at the end, all right, which is of course your last name. Now, when we say nomenclature of alkanes, we're actually interested in how we can name alkane structures. And basically, alkanes are organic compounds, all right, that contain single bonds. If you look at these structures, you realize that they are all single bonds, okay? And they have a hybridization called sp3 hybridization, all right? And of course, the members of the alkane series are the methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. These are the 10 members or first 10 members of the alkane series. All right. So basically, let's just look at an overview of alkanes before we actually look at the nomenclature of alkanes. All right. So now please take down. Alkanes are single bonded organic compounds. Alkanes are single bonded organic compounds with the general molecular formula CnH2n plus 2. Alkanes are single bonded organic compounds with the general molecular formula CnH2n plus 2, which also exhibits the sp3 hybridization. So this is how they hybridize. This is how they form new molecules through the sp3 hybridization. All right. When we're looking at hybridization, I would expound more on this. All right. But just note that the mode of hybridization is called sp3 hybridization. Now, full stop. The first 10 members of the alkane series, and their molecular formula, are as follows. So now the first member is methane. And methane has a molecular formula of CH4. Now everything amalgamates from CnH2n plus 2. That's where it comes from. Alright, CnH2n plus 2. Okay? So the N here is the number of carbons. So when we say methane, we are talking about an alkene that has 1 carbon. So if we impute it into this formula, you realize that we'll be having C1H2 times 1 plus 2. 2 times 1 is what? Plus 2 is what? That's why we have CH4 here. And one thing I need you to understand is that for alkanes increases with 1 carbon and 2 hydrogens. Now the second member of the alkane series is called ethane. Ethane is C2H6. Ethane is what? C2H6. C2H 2 times 2, 4 plus 2 what? 6. Now the third member of the alkane series is what we call propane. Propane is C3H8. The fourth member is butane. Butane is C4H10. The fifth member of the alkane series is pentane. Pentane is C5H12. The sixth member is hexane. Hexane is C6H14. The seventh member is heptane. Heptane is C7H16. The eighth member is octane. Octane is C8H18. The ninth member is nonane. Nonane is C9H20. While the 10th member is decane. The cane is C10, page 22. Alright, so these are the first 10 members. There are other members, okay? There are other members of this series, okay? But these are the first 10 members. Alright, now, when we talk about nomenclature of alkanes, it's first of all important to know these members. Because by virtue of naming alkanes, we'll be making use of these members, which will be representing what we call parent chain. Alright? So they will be representing what we call parent chain, or the parent name of the structure. The parent chain or the parent name of the structure. But it's sacrosanct to understand that each of these members you're seeing here are increasing with one carbon. And it's actually in this order, it's actually in this sequence. There will never be a time propane will be 7 carbons. It does not interchange. Propane will always be 3 carbons, heptane will always be 7 carbons. Do you understand? So that's the idea. Alright? Now, another thing we need to actually delve into now is the rules for naming alkanes. Now let's now look at the rules for naming alkanes. Having known the first 10 members of the alkane series, let's look at the rules for naming alkanes. Alright? Okay. Now, number one rule. Count the longest continuous carbon chain in the structure. Count the longest continuous carbon chain in the structure. When we say longest continuous carbon chain, we are talking about a chain that is not detached. A chain that you would count and it would continue without going back. Okay? By virtue of naming these structures, okay, I will explain to you these rules. We'll practicalize them. That's number one. Number two, okay? Number the longest chain in brackets, parent chain. The longest chain is also known as the parent chain. Number the longest chain in bracket, parent chain, close the bracket. Alright? Which should be numbered from the end. That gives the substituents, the end that gives the substituents the smallest possible number. The end that gives the substituents the smallest possible number. So you number from the end because you have gotten the chain. So the chain, if you hold a chain, the chain has 2 ends, right? Is it not? A chain has two ends. Now, number from the end that you give the substituents the smallest possible number. Okay, full stop. Now please write. The substituents are also known as branches. Okay? Comma. And the common substituents for alkanes are alkyls, A-L-K-Y-L, alkyls, and halogens. Look at it on the board, and halogens, okay, in brackets, and halogens in brackets, Cl, Br, I, F. That is chlorine, bromine, iodine, and what? Fluorine. So when an alkane reacts with a halogen, that reaction is called halogenation. It's a common chemical reaction for alkanes. Alright? We also have what we call hydrohalogenation. So all of these things will be discussed deeper and more expansive in your Chem 1-3 to your Introduction to Organic Chemistry. Okay? So now, look at these guys. These are the halogens. Alright? So we are saying that the common substituents or branches for alkanes are what and what? Alkynes and what? And halogens. Alright, have you taken note of that?
Yes.
Beautiful. Now, number what now? Number 3. Rule number 3. Rule number 3. Okay? Attach numbers to each substituent in the chain. Attach numbers to each substituent in the chain. Attach numbers to each substituent in the what? Chain. Depending on the carbon they are attached to. Attach numbers to each substituent in the chain. Depending on the what? Carbon they are what? Attached to. Okay? So the carbon that they are bonding with would actually determine the number that you attach to that particular substituent. Remember, you must have numbered that particular chain from the end that will give the substituent the smallest possible number. That's the rule that precedes this. Alright? Now let's continue. Rule number what? 4. Rule number 4. For substituents which appears twice, thrice, for substituents which appears twice, thrice, or 4 times, for substituent which appears twice, thrice, or 4 times, we use prefixes. We use prefixes such as di, tri, and tetra, respectively. So any substituent that is appearing 2 times, you use di. Any substituent that is appearing 3 times, you use tri. And any substituent that is appearing 4 times, you use what? Tetra. It's very important to note that. Alright? Rule number what now? 5. Rule number 5. When naming alkanes, and all organic compounds, numbers are separated from letters. Numbers are separated from letters using hyphen, which we call dash. Numbers are separated from letters using hyphen, while numbers are separated from themselves using comma. What we call comma. Okay? Numbers are separated from letters using hyphen, while numbers are separated from themselves using what? Comma. Okay? Numbers are separated from themselves using comma. Okay? Numbers are separated from letters using what? Hyphen. While numbers are separated from themselves using comma. Full stop. Hence, there should be no spaces in the nomenclature of an organic compound. Hence, there should be no spaces in the nomenclature of an organic compound. Alright? Hence, there should be no spaces in the nomenclature of what? An organic compound. Please, when you're writing an organic compound, the name of an organic compound, please, there should be no space. Alright? There should be no spaces in the what? Nomenclature of what? An organic compound. Alright? Now the last rule. Sorry? Including the prefixes. Alright? Everything in the organic compound, there should be no spaces. Alright? Including the prefixes. Don't worry, when we name these structures, alright, you'll get to understand the rules better. Alright? Then please write. Lastly, organic compounds are named in lower cases. Organic compounds are named in lower. What are lower cases? Small letters, thank you. Organic compounds are named in lower cases and not upper cases. So there should be no time while naming an organic compound that you name using capital letters. They must be named using what? Small letters. Using capital letters alone is a failure for you, alright? Okay. So now, let us... Sorry? Even at the beginning. The beginning, no. The beginning, no. The beginning, no. Anywhere. Anywhere. It should... Okay, now let's name these structures. Alright? Let's name these organic compounds. Okay, the first one has carbons and hydrogens, which is expected. It's a norm. Alright? It's a norm. But the first rule is that we must count the longest continuous carbon chain first. We must count the longest continuous carbon chain. That longest continuous carbon chain is what we serve as the parent chain. Alright? So when we say longest continuous, alright? Now, we have, if you look at this now, we have different ends. We have this end, this end, this end, this end, and okay, this, and this, right? An end that does not have any other thing. Alright? We cannot say this now because, of course, it has a continuity here. So when you want to count the longest chain, you count from any end that has carbon. We cannot count from chlorine because we want to look for the longest continuous what chain? What chain? Carbon chain. So we can start counting from here and we'll go down continuous. It's not like this, then you come back. No. Alright? It's not something you merry-go-round. No. May it touch everybody. No. You understand? You can either count like this or you count like this. Alright? But you cannot count like this because chlorine is not carbon. But the idea is to count the longest continuous carbon chain. Longest continuous. So now if we count this way, we have 1, 2, 3, 4, 5, 6, 7. How many? 7 carbons. If we decide to count like this, 1, 2, 3, 4, 5, 6, 7, 8, how many? 8. So is that the longest? Yes. So what you have to do, just barricade it like this. So you'll be able to take note of the parent chain. So this is the parent chain. As simple as that. You count the longest continuous. Like this would have been continuous. It's continuous, right? But it's not the longest because we have 1, 2, 3, 4, 5, 6, 7 carbons. So now this is like the parent chain. Now anything that is not in the parent chain is called a substituent or a branch. Anything that is not in the parent chain is called a what? Or a what? Or a branch. So this is a substituent. This is also what? A substituent. Alright? So whatever is not in the parent chain is known as a substituent. Alright? So you circle it like that. Alright? Now, when you have been able to identify the substituent, the next rule is to number the parent chain from the end that will give the substituent the smallest possible number. Number the parent chain from the end. If you look at it now, you realize that this is an end. This is also what? Before now, when we did not have the parent chain, we had different ends. Here was an end, here was an end, here was an end. But in a chain, you have only 2 ends. Okay? You have only 2 ends. This thing is just like you taking it and stretching it. From here, holding here and stretch. That's why it's a chain. Even if it's like this, it's just like you taking a necklace and forming something like this shape like this. If you take from here and you stretch it, will it not be linear? So this is a chain. This is a chain. Alright? So this is a substituent. This is also a substituent. Now remember I told you that alkanes usually have the most common of substituents, which are called the alkynes and of course halogens. Alright? If it's not